Hi everyone, and welcome back to Mondays with Miss Meredith. Boy, do I have something exciting for us to do today. We're going to do a special experiment that is going to cause a reaction. It's going to get messy and it's going to teach us about fluid continuity. So we're going to have to head outside to do this. But before we do that, I do want you to know that if you try this at home, please make sure that you have your parents' permission and make sure that you're in a safe space. So what you're going to need is a soda and some Mentos. I bet you know where this is going. This is going to be fun. So let's head outside.
Let's get started. We're going to start with our soda and our Mentos. I'm going to open the bottle. Then I'm going to get ready and take some of my Mentos out from the packaging. The more Mentos you use, the more of a reaction you will have. I'm just going to use a couple for this round. Let's observe what happens. Now let's talk about why this happened. The fluid continuity equation is when a moving fluid is forced through a tight space, such as the hole in this soda. The reason that soda is so bubbly is because carbon dioxide, CO2, is pumped in to give the drink its fizz. The CO2 binds to the water molecules H2O in the soda, but only lightly. It doesn't take very much for CO2 to escape. That's why the drink always foams up when you take off the lid. Something that can speed up the release of the CO2 is dropping something into the soda. At first glance, Mentos appears smooth, but under a microscope, you'll find that their surface is covered in tiny bumps and pits. The suspended CO2 breaks away from the water molecules by forming bubbles on another surface, a process known as nucleation. This sudden buildup of foamy liquid has to go somewhere, so naturally it seeks to get out of the bottle. Being forced out of the narrow neck means it comes out at a high velocity, thanks to the wonders of fluid continuity. This is what gives you that explosion. Thanks for watching!